like all the information is there, and it's pretty cool. Like I liked it. I'm gonna keep doing it. I'm gonna try to do one day, see how far I get. The guy who teaches it, I think, was the president of
vote for it too.
Okay, cool. Yeah,
Sorry,
I like it because
like,
oh shit, yeah, my internet's really bad sometimes here.
Welcome to Spectrum. Yeah, I didn't mean to interrupt. I was like, oh, he's done, and then David's like,
Yeah, this looks pretty cool.
Yeah.
Well, I just started recording this from my personal laptop. I've never been able to actually get a recording on Zoom with the actual video. Like, it's always only the audio. So.
Oh yeah.
Yeah, this time.
So we're not losing anything.
Yeah. So hopefully this is the first session we ever have that's actually recorded.
Nice.
Cool.
But yeah. Does anyone want to run through anything cool they've been doing? If not, I mean, I'd be happy to run through what I've been working on.
Now I can teach you all about conch for a little.
I'm down.
Yeah, I could also talk about Lambda Calculus if anybody's ever interested in that.
I'm down.
What is...
you can give me like a rough overview, like just put it in my head of what it is.
Yeah. Alright, let's do like a 15-minute session then. How do I share my screen?
You click the screen share button.
Shit.
It should be like right underneath Sherrod, I'm guessing.
No.
Right next to the little turn on camera.
There's a... It's just user settings.
Like the left.
Sorry, say that again?
It's y'all sent a screenshot. It's right.
Text and images.
It's the left. It's the leftmost icon underneath.
Video and screen share are not supported in this browser. Please download our desktop client.
Oh, are you in a browser? Yeah, you gotta go to desktop, dude.
Oh, damn, I didn't know that. Shit. I gotta build it.
It should be an AUR.
Oh, okay, cool. Do you know what it's called by chance?
I don't know, yay AUR, or yay Discord.
Discord.
Are you gonna plug into the screen share?
No, I'm just trying to get the desktop client.
Oh, got it.
Yeah, it's just Discord.
What browser are you using? Are you using Firefox?
Yeah, exactly.
Yeah.
I heard some whispers that Discord's gonna release server folders. I don't know what that means, but maybe like folders for channels and servers, maybe.
Wait, are you all seeing someone's screen?
Hey, what's up, Dave? Oh shit. I just X'd out of it. Hey, I'm back.
What's up? Ripcord in AUR? That's the real question.
Huh? Oh, no, I'm still in browser. It's still down installing.
Oh, but Ripcord is in AUR. That's sick.
Ripcord. What were you saying, Sherrod? What are they bringing to Discord?
Server folders, I think. Not sure.
So basically, you can do what Ripcord was already doing.
I guess so, yeah. But Ripcord is nice when it's like when I need something lightweight. You know what I mean? But I don't really like it as a full Discord.
Well, if somebody else wants to go first, my thing is still installing.
Okay. Edmund.
Yeah, sure. I'll just get through the little like sci-fi thing that they did. Y'all might. I don't know if like I mean, I guess Jay might be the only other person who's spent a lot of time customizing their shell.
Oh wait, so we're talking about we're just going through people's customized like.
No, this is a cool little thing that I learned about at Sci-Fi and hacked on.
I was gonna show some Lambda Calculus a little later, but I gotta download Discord.
Yeah.
Set the whole thing. Damn it. Change windows. Application window. Home. Share. Did not change anything.
Wait, switch to only one screen, because if not, it's too wide.
Yeah, that's what I'm trying to do.
Oh damn! So I can't even see screens until I have the thing.
Rough. Okay, how about that? Does it just not like my terminal? Okay, it doesn't like
Still
me at all.
showing both.
That's weird as hell. Okay, well, I guess not. I'll just drop this in there and y'all can look at it if you want. In your own time. Basically, the whole idea is that then you have Python in your shell.
Python in your
And so
like
you-
as a.
So like you can code whatever you want in it, or I don't
Exactly. You can write functions. Basically, you can combine like shell stuff with Python stuff. You can do like basically you could get like ls. You could capture the output of that and then parse it however you want.
Oh my god, that's kind of crazy.
Yeah, it's just what were you gonna say?
What's the most interesting thing you made with it so far? Or you haven't got too much time to mess with it?
I actually don't use it because I've spent so much time with Z Shell that I'm like, yeah, I haven't invested too much time in this. There's no way you're getting me to switch ever. But basically, like one cool thing that I thought was, if I wanted to though, it imports all of your like functions, and you can source other scripts. So you like say you find some random bash script, you're not hosed because you don't use or you either Z Shell, Fish, whatever. You can import those and source those through it. And most of the time it automatically works.
Cool. I'm looking through the sledge. Conch.
There's also a video that goes with it. They're pretty cool guys. Yeah, you should definitely go to SciPy though next year, Jay.
Oh yeah, when is that?
I don't know, sometime, but it's in Austin at UT's campus.
Oh, that's awesome.
Yeah, I didn't know. I just went down there for the sprints because I was like, I'll check it out and see. And then it was, I don't know, it was wholesome. It was just like people wanting to do computing.
Yeah, I can imagine.
No, like money involved.
Nice. Yeah, there's a conference I was checking out. I've looked at it for a while, but it's in September. It's coming up. It's called Strange Loop. And it's just a bunch of like weirdos that are all like into just like really interesting stuff with computing. I can put a link to it. Some of the talks
Oh yeah,
are,
cool.
yeah, really nuts.
St. Louis.
Yeah. Yeah, like you've got damn, where was it? Something about Wikipedia. It's like understanding like how Wikipedia like runs on bots more than it runs on people. So like bots are taking care of all of our like archiving of information.
What the hell? It's not like in one. It says it's like in U.S. New York, U.S. Missouri, Jeffersonian, U.S. Frisco, Burlington. What is this?
Really?
Are those just different names? Oh, they have Elm Comp there. Damn, this looks cool.
Yeah, I'm thinking about going this year. If anyone else is interested, could split room costs.
For which one? Because there's PWL conference, M conference, TLA conference, pre-conference.
Yeah, I'm not exactly sure yet. I might want to go to all of them, but they're all at the same time, so I'm just not
Oh,
sure.
so it's oh, okay.
Yeah,
I just
I think it's kind of all in the
different.
same place.
Papers we love conference.
If I had to choose that one, it would probably, or one of them, it would probably be that one.
St. Louis, Missouri.
Sweet. Okay, I'm gonna hang out for a second. I'll be right back. Can you hear me?
Yeah.
Nice. Cool. All right, now I have the turn on camera option and the screen share option. They only let me do 720p, but can you guys read the text on this page?
Yeah, that's fine.
Okay.
Yeah. Where's the Discord screen?
So show something else besides Discord?
Yeah.
Now.
Yeah.
Yeah, we can read it.
Cool.
Let's go. Yep.
All right. I think it's making my computer freak out a little bit because like y'all are a little more choppy, but
Yeah.
it should be okay. All right. So I'll just do it here. All right. Is everyone ready for this? I've been wanting to show this for some time.
Nice.
All right. So first of all, does anybody know what a calculus is?
No.
Anybody like?
What's the difference between like a lambda calculus and I don't know
And then
calculus?
Yeah, calculus.
Yeah, a calculus. Yeah, so calculus has maybe some correspondences, but that gets like really theoretical. But a calculus is just a formalism. In this context, it's a formalism for computation. So specifically, it's not a language, and all languages are built on top of some kind of formalism for computation. So 99% of all languages are based on either the Turing machine, which is a formalism, or the Lambda Calculus, which is a formalism. They were both invented in the same year, and actually there were 3 invented in the same year. The other one is Kurt Gödel's incompleteness theorem and his theory of recursive functions, there's a really interesting theorem called the Curry-Howard isomorphism that basically shows that all programs are actually logical statements, and that you can tie perfectly between software programs and algorithms and mathematical logic, and therefore prove all these weird things like the incompleteness theorem about logic is equivalent to the halting problem that Turing came up with. But that's a whole bunch of stuff. The point is that a calculus is not a language itself. It's a formalism for computation on which languages are designed. So the Lambda Calculus is specifically the root of all functional programming languages. So any functional programming language you've seen is based on this Lambda Calculus. So the Lambda Calculus is pretty damn simple. It has 3 different expressions. Well, 3 different terms, sort of. It has a variable, so say some x. It has an application, which I'm going to put this as like the lambda sign. Do y'all know what the lambda sign looks like? It's like...
Half.
Let me see if I can... Yeah, that's the lambda sign. So we're just going to do a slash and then say x dot n, where n is a term. And a term is just anything more. So you can do... do y'all know like context-free grammars or anything like that? Y'all still here?
No.
I forgot.
it's okay. So this is simple. It just means that some term or some expression n and some expression m is either, or we could even start more simple. So some expression in this language is either going to be a variable, some x, or it's going to be what we call a function definition, which is lambda, and the function lambda takes a variable x and then runs this term. And this term recursively is either a variable or another function definition. So this would be a valid expression in the language, just x. Or if we say specifically that x is like 0 or something like that, or 1, those would both be valid because they'd just be x. This would be valid. We could say x dot 0, or even x dot x. This would be another valid one, x dot x, or y dot 0. Does that kind of make sense?
Haskell from Principles also has a good intro to this.
Yeah, so it's
Can you explain
basically
the-
just recursive definitions. So everything is either a function definition or just a variable itself. And then you have one more thing that it can be, and that is called the application, which is just some term with another term. We denote it like that. So we could say for nm for two terms. And so an application would look like maybe n would be some function like this, x dot x, and then some value, 0. So 0 is applied to this function, and this could reduce to, like, this function right here takes a variable, and since it's applied to 0, then x becomes 0. It evaluates the inside, x is x, so it replaces all x's with zeros, and this just becomes the function 0.0, which would return the term, which would just be 0. So this right here, the part to get is that this is the formalism for all languages. All functional languages can be derived from these three terms right here, which is a variable, a function definition, and an application of two terms together. Does that make any sense?
Yeah.
Yep.
Cool.
Yeah.
So you get some interesting things like you see in Haskell, one of the most powerful, and this is in Scala too. Rust unfortunately does not have this, but that's because you can't do it easily without kind of making some kind of abstraction that costs memory. But something called currying, which is when you, so if you look at this function definition right here, it only takes one variable as input. So how do you get two variables as input to a function? Well, you just make a function that its in term, which is n, just takes in is another function, and then we could say like xy or xy. So this returns xy, and this is called currying because now we have a function that returns a function that returns xy, and that's functionally equivalent to xy dot xy. But because we did it this currying way, where you're really defining a function that returns another function, you can do really cool shit like partial applications. Like you can do, if you have a function add, which in Haskell would take two numbers, x and y, and add them together like that, then you could create a function called add1, which just takes one number and applies that number to add with a 1, like that. So this right here is a partial application, or add 1 could be considered a partial application. If that makes sense.
Yeah, that makes sense.
Yeah. So, okay. I feel like this might be getting away from the main point, which is let's look at this website. So there's this really awesome resource for a class on programming languages. And I can link this too. But so they start with just some like learning all the things. So basically we have to have a way from this very simple calculus to derive all the things that you need in a programming language. So specifically, some things we need numbers. We need to be able to represent numbers. We need to be able to represent Boolean types, recursion, and that's, I guess, most of it. So from recursion, you can get any kind of looping, and from numbers, and we have functions. So this is like most of what we need to define pretty much any language, which is interesting. But let's look at how they actually define numbers in the system. So they define 0 to be, specifically down here, a church numeral for n is a lambda calculus function that takes 2 arguments, f and x, and applies f to x a total of n times. So we have a lambda function f that returns a lambda function x that returns x. And let's just call that 0 because it applies, f applies x 0 times. Then that means that 2 is that same function that returns a function that applies that outer function, f, to x twice, which is done with the application. So this is one application, which is this third term up here, and then another application here. So it's kind of just like numbers are defined recursively. So s of 0. So it's almost like every time you apply a function, you're adding 1 to the 0. Yeah. So yeah, I don't know if it's worth like coding this up in JavaScript, but it's really easy to do. So like the interesting thing is with just this little bit of knowledge right here, you could go and like define, a programming language that's pretty damn powerful just like off the bat. You could start defining functions that do all kinds of arithmetic and everything like that. So we've got the plus function. They define the plus function to be a function that applies m to some number. So it basically takes 2 numbers, m and n, and it applies m to, let's see, that's f of x, n applied to f of x, which then takes f, which is, Does anybody want to take a shot at encoding what this means?
Plus lambda takes a function n, which takes a function f, which takes a function x.
So I mean, you can compress it a little bit. This part looks familiar to the numbers above. Like, so we know that this is 0, which is no applications of f on this function x. And can you see that this right here is the identity function? It just takes something and returns it.
Returns it. Yeah.
Yeah.
Whatever it could be a function or
Yeah. So 0 is just a function that takes the identity function and just returns the identity function. Actually, it doesn't take it. But so it's weird. You could define numbers on like any kind of function. It's more of just like an abstract concept here. It's like any function that you have. So these could be represented in JavaScript if like the identity function was, like what's the equivalent of the identity function in JavaScript? Just, I guess, this or x is the identity
the return
function.
X.
Yeah. So if you define some function, it's like, I don't know, what would be an interesting case of this beyond just like, so I mean you can do it for the abstract sense of take a function and return the identity. But it could be, I don't know, my linear algebra teacher always liked to use cheetahs. It's like you take some cheetahs and you apply cheetahs this many times. Just because it's like literally anything. So it's more about like the structure than it is about the actual thing itself.
So
yeah.
F takes X and performs the operation. MF. Yeah, I don't know what that. Like M F parentheses N F at the very end.
Yeah, it's pretty confusing looking. So let's say that N takes an F and an X. We basically are applying F of X N times here, whatever N is.
So that'll create a number. The number will be N.
Yeah, exactly. And then here, M similarly is going to take an F and this number N, and it's going to apply F to this number N times.
So it's like a multiplication of N times N.
Well, no, it's only an add because here F gets applied N times, and then we take the resulting number, which is this, and we apply F M times from here. Because remember, all the definition of a number is a function that takes a function and something and applies that function to it some number of times. So N is defined here as something that takes a function and an X and applies F to X N times, and then M takes that same F and this new number that represents N and applies F to it M times. So that's plus. Multiply. Dave, can you take a crack at this one?
Okay. So we're defining how many times we have to run F itself, and that'll be no.
Well, just start from the M function. Like, so we know that it takes in something or two things, a function F and an X. So it's basically taking in N of F is its function that it takes in, and x is the thing it's applying it to. So this gets pretty cool. This is where you can start to see the power of like the generalness of the lambda calculus. We say it takes in any function. So remember that n takes two input parameters, and a function and an x. But here, n has only taken in one parameter.
Yeah.
So, again, we're currying. We're doing a partial application because we haven't given it an x yet. So what this returns is a function that takes an x and then applies f to whatever x is n times. Does that kind of make sense?
Huh.
Yeah.
Yeah.
Okay.
So this is actually a function right here. And so m is taking this partially applied function and this same x, and it's applying this partially applied function to x, which means that it's going to apply to x the function that applies f to n, or n f's m times.
NFs.
So is n the number of times that it applies f?
Say that again?
Is n the number of times that it applies f?
Yeah, that's what this function right here would return, is a function
Gotcha.
that takes an x and applies f to it n times. And so what we're doing is we're applying this function that takes something and applies f to it n times, and we're applying it to this x m times. So it's like a double for
Gotcha.
loop. Basically says for each m, run the function n on x, and n says n times run f on x. So we basically get this double for loop of running n m times, which is a multiply. So that's cool. Booleans are even cooler. They're kind of nuts. And then recursion is the coolest thing. It gets in like a fixed point operator, and it defines how you can define recursion generally. But I won't like have us sit through all of them. I think it's just the ideas here are really powerful because you can really see like the importance of like currying and like partial application, and how you can get like such power from such like raw and simple rules. You know, like we started from just those three basic assumptions, which is variable, function definition, and application of terms. And from that, like when you start coding in Haskell or really any functional language at all, even like Scala, Elm, I don't know what some other good ones are, but you know, functional languages are becoming a lot more popular, I think. But yeah, it's just when you can see like from the Lambda calculus, then you can very easily see from any functional language how it should work. And yeah, I think that's interesting in its own right. Let's see if there's some things else I can show with it. I really wanted to show this because I want to show some like Haskell, which or like show some of the things that you can do, like some of the ideas in Haskell, like the monad itself. Like, has anybody heard of the monad? Probably Edmund.
I
Heard
have
Yeah.
Yeah.
the monad. I like how you refer to it as the monad.
Yeah, it sounds like it's super special.
Dude, it's like so special. And once you learn it, you'll start seeing it everywhere in your code, but only in the best parts of your code that are really easy to work with, because that's what the monad is. It's how people teach object orientation in school, and they teach it like this thing that allows us to build like Lego blocks that are super composable on top of each other, and it all makes sense, and you know, square and rectangle inherit from shape, and you know, like it all kind of just makes sense. But then in practice, like you get all this messy code, And it's because object orientation is not really composable. The true composable ideas that we all wish we were working with that would make code extremely simple all comes back to the monad itself, and functional languages too. But when learning like the monad, you can really start to see the essence of like what programmers are trying to accomplish when they're building, code, and build it in a way that like you can really abstract away things and make things really simple. And there's some really good examples on it too, but we can save that for another time.
Yeah, I need to watch a YouTube video as like someone sent it to me. And,
On monads?
Yeah.
Yeah, let me pull this up really quick. So if you don't know Haskell, it might be a tough start. I mean, this book is a great introduction if you're interested in learning it, but specifically, let me pull up the monad section.
I thought it's a
Just all of
concept. Does the language matter?
It's a type class also.
Yeah. So it's just an idea. Haskell captures it pretty well. Some other languages can capture it even better than Haskell can. But it is just a concept. It's just that in a language like JavaScript or even Rust or something, they're not abstract enough to be able to capture the idea of a monad, because the monad is so abstract. It applies to everything. Like async and await, that's a monad. Any kind of future is a monad. Any kind of like I/O operation can be considered a monad. There's lots of different things that are monads, and you can start to build them yourself. In most languages, they exist everywhere, but there's no like unifying type class saying that these are all monads, and therefore you can kind of interchange them and play with them. In Haskell, they have the concept of type classes and higher kind of types, and so you can define these more like abstract things. So this is literally the type class for monad, which just has the bind operator, which shows how you compose monads together to create new monads, which is kind of just like building a Lego city. But they have this great example called walk the line, and in the example, it's really simple. It's just he's basically simulating birds landing on the French guy's tightrope pole balancing pole, and an uneven amount of birds. We basically just want to represent the simulation of birds landing there and taking off. So he defines a pole type, which is just a tuple of birds on each side, and a bird is just an integer. And then he starts defining some functions like land left takes some birds and a pole, and it returns a new pole because this is a functional language and it doesn't have state. So it takes birds, which is an integer, and it takes a pole, which is a tuple of some integer left and integer right, and it says return a pole that's just left plus the number of birds and right. Same for land right. And then we can start using this function. So we could say 2 birds land left, and so now we get a new pole that looks like this. And so we can start actually, this is where you start to see the monad pattern in here. We can actually apply these to each other. So this is a pole, but also this is a pole. And so is this a pole. And then
Because it returns the type pole.
Exactly. So you can start to see how they compose a little bit. But it's not just chaining that makes something a monad, but that is definitely the feature you see of it. And when you see things like map or filter or reduce, all of those are functors on like a monad usually.
Okay.
Yeah, it's kind of hard to say, but and then Haskell, just like Lisp or something, can do a lot of really cool DSL syntactic flavoring. So they define this new function that basically just makes it so that we can say, take a poll, land left 1, land right 1, land left 2, almost like a story. And you can imagine this in code, like, just iteratively building on something. Maybe it's like a web application, and every time the user sends something, you want to modify an existing thing, but you want to do it in this story fashion where that you're not getting any random side effects. You're just composing on something that already exists. And then I won't keep going because you should read it, but he basically shows how you can define a monad on it and bind these together. And then you get these really, really powerful features about how you can express this and the amazing things that you can do with it, and what happens if you fuck up, or somewhere along the chain of composing an error occurs, or the bird simulation is literally impossible or something like that. Then what happens to the compositions and things like that. And most modern object-oriented designs, we get really confused on errors, like throws, exceptions, all these things that have to percolate up through the system and be handled at different locations, and maybe one of them handles it and maybe one of them doesn't. That's all confusions from our basic problem of designing things with inheritance instead of designing things as monads. So just this simple example right here can really capture that essence. And then he goes on to extend it with bananas and other shit. So
Great book. Sounds like.
anyways. Yeah.
Can you drop?
Sometime I'll get a more relevant example for y'all. I've been playing with Elm a lot recently, which is it's a purely functional language. It's a much simpler Haskell, and it compiles to JavaScript, so it's totally a front-end design language. It's really cool.
Damn. Yeah, it's a purely something. Yeah.
Yeah.
Wait, who was showing us that last time? Was it Edmund? Or was it you, Jay? Or a while ago?
I remember Emmett talking about it.
Yeah, it was
I think we both talked about it. We're both kind of here.
Yeah. Yeah, it was probably you and my friend Riley that got me started in Elm, and I've started to really like it. You get a lot of nice features about it also has type safety and strong types, so you as you're writing these crazy messes of front-end languages, especially HTML and all that, it has the same features of React, where you can define a function in Elm that returns the HTML type, and an HTML type is just a recursive abstract syntax tree of HTML. So all of a sudden, all of your HTML and all of your CSS becomes type safe, and you can separate it into components just like you would React. But you can even go farther because you have partial application of functions. You can do crazy shit that returns a partial application of HTML, but is really just a template for you to make a post or something that is specific to each post, but it's really just a function. It's crazy shit.
Gotcha. This is the story of how Jay got into web development.
Into front end, yeah.
Yeah.
That's the only way to reel him into it.
Yeah.
It's got to be complicated.
No, it's gotta be simple, dude. That's what stopped me from so long. Is it's so much to learn, and it's so complicated. And I write the JavaScript wrong, or it gets unruly, and there's a whole bunch of different ways to do it, and I just start getting confused and I quit.
You said, oh, you were saying, yeah, it was you. You said you're building your website with it, right?
Yeah, that's right.
How much progress have you made with that?
I mean, so visually, not a ton, but I can kind of show a little bit of it.
The back end is gorgeous, though.
Yeah. So that's definitely. Oh shit. Man. So it's all kind of a mess in one file because I haven't broken it up. I'm still learning about breaking it up into files.
Yeah.
Let's see if there's a good piece to look at here.
I want to see state management.
State management? Okay.
Mm-hmm.
Yeah, so basically, when you compile to JavaScript, it compiles with a runtime. So that's how they get the statelessness, is because there's actually something going on, a loop going on behind the scenes that passes back into what's called the update function right here.
Uh-huh.
The update function takes a message and a model, and it returns a model and a command. And so a message type is actually defined by me right here. So a message is a sum type or like a union type, which means it's either a carousel message, which is a carousel is a bootstrap thing,
Yeah.
or it's a link clicked, which I can use to capture when they click a link on my site, and instead of refreshing the page, have it, or have a function that handles redirects and like links clicked or URL changed.
So these are for specific events, right? When they occur, and you can only capture the events that you define over here in this struct or whatever it's called.
Yeah, but it's these don't really show like how custom this can be. I can define a type that says increment like this,
Uh-huh.
and then down here in the update, I can say if message is of type increment, then
Do whatever.
take the model and say we have some value in the model that's I, and we return a model, so we actually say, oh shit, we say the syntax is take this model and return it, but actually change its field I to I+1. That's what that says right there. And then the command message, we can just say I have no command, so we return a new model that increments I based on the message that I defined. And then down in the view right here, which takes a model and returns a document, which is like an abstract version of HTML. I can put somewhere on my page. See, this is HTML right here. I have title and body.
Yeah.
I can say shit. I could say button. I think that's the attributes of the button, and then shit. I'm trying to remember how this works, how buttons work. I think I returns a document. Shit. What am I forgetting here? There's a render home. I'm trying to remember how you how I could call a command basically. It's been a few days since I've worked on this. So the view just gives a document, and we have to handle okay, so here's like the carousel stuff. Damn, I'm kind of already forgetting, dude.
I mean, that's fine. So you're just showing that, depending on, suppose it was nothing and they went to the wrong route, then you just built that page that you're right there, right? Like.
Yeah, exactly. And here I define like some posts. So like viewLink post 1, where viewLink is actually a function that takes a string and returns some HTML. So and
it's defined right there, yeah. Huh.
Yeah, and so I can start composing these together.
But then, so what I noticed from at least how you have built it it's very like you have functions to do very small things, right? Like I understand it makes it easier to break it down. Like suppose okay, the 404 page or like this, like convert, I don't know, do something to a string and make an HTML or whatever. But doesn't that make it, I don't know, a little more confusing? Like having so many pieces here and there versus like from a typical HTML code, it's like okay, I can see my whole current page. I don't have to like parse through each piece. What I'm getting at is it seems like it makes it a little, like from a logical perspective it makes so much sense, but from a perspective of like reading it and just like okay, this is what's going on. I have to like step through basically.
Step through stuff. Yeah, I mean, I guess that's kind of just a matter of personal opinion, but I mean, you could still like write this in explicitly here. But I mean, would you not do it similarly?
How you choose to.
Yeah, would you not do it similarly in React or whatever it is that like instead of defining li and the aref hyperlink each time?
Well, it depends on the context. I mean, but as a general rule, I don't really break it down that much.
Yeah. Yeah, for me, I feel like it would be useful if you start having, just like a ton of links.
Ton of links. I mean, that depends what kind of links. If it's just like something modeled an object, then you can do like, take that object and make a bunch of like buttons or whatever from it, which is super simple syntax in that. Yeah. I guess it is just how you choose to work with it.
Yeah. Trying to think if there's anything else that's like obviously cool. Here's the whole state that you define in the program. So I think that's kind of a similar concept to React. Yeah. Yeah. But
what since it's you never directly modifying the state or anything, right? It's always like we take this, we like make a new version of it and maintain that. So you never modify the original.
Yeah, exactly.
That concept is forced upon here.
Yeah. And in the backend, they can do a lot of optimization, so you don't literally have to copy every time. Like this right here might actually modify the underlying JavaScript state, but when we're reasoning about the program, we don't have to think about state or side effects or anything like that. Everything is very like safe and type safe.
It has a name, I forgot, when you do this, where you just like have to return a new copy. Damn, I don't know.
I don't know.
I guess it's mutability, right? Technically.
What is it?
I think it's the concept of immutability.
Immutability. Yeah, definitely. Yeah, I mean, statelessness and immutability are pretty close together. It's just like program immutability almost. Yeah. But yeah, if anything, it's just a fun way to like practice functional programming too.
Yeah.
Anyways.
That's pretty cool. It's a lot to take in.
Yeah, I wish I knew how to teach it better.
No, you did a really good job. I think I understand the basics.
Yeah, and I mean, like, it's also like guiding us. Like, so one thing I realized is it's never, like, functional programming never really clicked for me. Like, sure, I can do shit, right? But it's never really click. But I see now that maybe if I take the time to properly understand Lambda Calculus, all these things it'll hopefully click, right? Like, it'll give me a base. Going from the roots and having it click, and then going back to the function programming languages and thinking that mentality, I think will make a huge difference for me. At least this is what I pulled out from this session.
Totally, yeah. That's definitely what I'm getting at is like there's all these like different functional languages and like all these concepts you see even in JavaScript about like the map and reduce and stuff, and you hear that they're functional, but you're always like, well, how are they functional? They're just like more features. But
exactly,
if you can just understanding the Lambda calculus itself, all of a sudden you just start seeing it everywhere and you see what being functional really means. And then it becomes really easy to pick up functional languages because the first thing you do is ask the questions of like, okay, how does currying work in this language? How does like function application work and all the different things that the Lambda Calculus has.
Going bottom up instead of top down. At least I always go top down, which is definitely not the best way.
Yeah, but both are good for sure. And Haskell is so freaking cool, dude. Starting to think in terms of Haskell just helps with everything else. Or really, it doesn't have to be Haskell, but Haskell's one of the simplest languages because it tries to bring it back to its roots. Other languages try to capture a lot of these concepts, like Rust and its traits system. But thinking in terms of type classes instead of in terms of inheritance is like the most important shift that you can make in your programming career. I swear, dude, people make their lives so hard by using inheritance and like the old idea of object orientation, which is truly just based on legacy code that was designed by people that thought they knew how they were building things, and then it just took off, kind of like the SQL language. Like, it's not a good language, it's just the biggest language. And we're slowly seeing this shift to the type class trait style of programming, which is actually how logic works. But it's a slow thing, but it'll help you design your programs in a way that will just make it more readable to other people and make it way simpler to reason about yourself and maintain in the future.
Even if I'm doing old school Java?
Totally. Because in Java, you'll start using interfaces more instead of inheritance. And when it's applicable, you know?
Yeah.
And then you hang out in functional programming groups and get talking to weird people and doing cool stuff.
Yeah, definitely.
Yeah, I would like to go down that path. I hope.
It's a dark road.
He'll never come out of it.
Yeah.
Yeah, it's definitely slippery because you can start just appreciating things for the beauty instead of for its like practical use. But I try not to slip too far. I know tons of people that have.
Yeah.
But I mean, I get so worked up about this. Just like with my work, I'm mostly developing in Rust, but then I'm also working with my boss's C++ code, and it's like a medium-sized project. It's fairly large, but it's so complicated to work through because of like the way that he designed it, and it frustrates me so much. And I know that if I implemented this thing from scratch in Haskell or even Rust, I could have it done in like a fucking week. Basically all of the stuff he has.
But if you told him that, you'd be like shitting on him, right?
Yeah. I mean, there's a lot of like extra steps, but it would be a great start. But the biggest problem is that he doesn't understand Rust code very well, and he definitely doesn't understand Haskell. So, yeah, I wish I could restart, but
And just like a general comment as a whole, also that's the issue with the general CS community as well, right? Like, okay, maybe not the passionate people, but just like for these things to be used, it just needs to be easy enough for people to understand, or like for them to think in that way, right? Like, people are just on the old school ways that they just don't want to change from thinking, like how we can use functional programming more, or whatever the case may be.
Yeah, people are not like, when you have a job and everything and you're trying to get something done, it's like it's a daunting thing to like pick up something new, fresh.
Yeah,
exactly. And then you have to convince all these people. You're like, okay, so you don't need 100 people. You could probably get by with 5.
But how do I convince my business people and tell them all of that? Like,
it's a pretty odd for them. I would think they'd be like, oh, so you're telling me I don't have to pay that other 95 people? Cool. And they'd be like, boom. But they probably wouldn't believe you because they're gonna be like, that sounds too good to be true, which it probably is.
But not only from that concept, like, look, just thinking in terms of, okay, like, so like the new project we're gonna get is gonna be 50, 60 people, right, overall, versus now it's like maybe let's say 20 people. So just also getting consensus on things. So sure, just to even implementing certain best practices. I'm not gonna call that's like, oh, let's do a new language, but even best practices is still a different way of thinking. I don't know, like, So like it's hard. I don't know, to get consensus with people.
Let's debate linting for 5 days.
No, we're gonna have a lint file. I don't give a shit. You throw your code in the commit, it automatically gets lint with those rules.
Jesus, I'm still fixing stuff in block and key that didn't like get linted properly.
Oh, yeah.
No, I figured out what it was. You were missing. There was something in there. I think you were missing some file. I can't remember. Something wasn't installed properly, and then I like found it. I'm like, holy shit, we've been doing this for like 6 months, and it hasn't actually been running. Because you put it on quiet or whatever whenever it runs.
I think I had. Oh yeah, you had enabled it and then broke some shit. I was like, fuck this. I don't have time for this. And I think that's what had happened. So I rolled back a commit or whatever and just removed it or something.
Gold.
See y'all.
See you, man.
Alright.
Good luck doing a tennis match.
Wait, and then is Ryan still there? How's he?
Surprisingly, yes.
Is he holding out?
He basically told us last week. He's like, I like. He was just like so flustered, and he's like, I